Hey guys, welcome to our flipped video lessons here about solving single variable linear inequalities. Now before we move on with that, remember that you can do corrections on any test or quiz. So the test we just took on our single variable linear equations, you can do corrections, you can do meet with a math teacher, get them signed, and you can do a retake to improve that grade. And it's going to be important, you'll see in just a second, that we make sure we understand all of our stuff about linear equations because it's going to carry over to our linear inequalities, right? So as I just said here, the good news about linear inequalities is everything we did with equations is going to come back over. So you can see fractions, parentheses, like terms on the same side, variable terms on both sides, our two-step equations. All of the steps we used, all of the processes we used to solve equations, to get x alone, to find what is going to make the equation true with our equations, we're going to bring back with inequalities. So let's just take a quick look at an example here. If any of these steps do not seem familiar to you or confusing to you, you need to get some help so you can catch up on these. First thing we have to do is get rid of the fractions. So we're going to take the least common multiple and multiply every term by 21, except for what's in the parentheses. Then I'm going to distribute the negative 41 to get rid of the parentheses. Then I'm going to combine my like terms, the 3 and the negative 189 on the left-hand side. Then I'm going to get my variable terms on the both sides on the same side, by adding 41x to both sides. And then it's a two-step equation, cancel the constant, cancel the coefficient. Again, guys, if any of the stuff we just went through pretty quickly is confusing to you, you've got to come in and get some help outside of class. This is stuff we expect you to know moving forward here. Now, there will be some differences because we're no longer dealing with equations, we're dealing with inequations or inequalities, right? Things that are not equal to each other. And now that we're not equal, we can't use just an equal sign. We need some new symbols to use in our inequalities. And we can see these symbols are is greater than, is less than, is greater than or equal to, and sorry guys, that should be is less than or equal to, not less than or equal to. These are our new inequalities. We've got to be able to read them and translate them properly. So let's just think about this inequality here. This is saying x is greater than 7. So list some numbers, just think in your head, what are some numbers that would make this inequality true? Well, hopefully you came up with any number that is larger than 7, 8, 9, 14, 31, 74, and so forth. You can see we can come up with a lot of different numbers here. But the question is, how many numbers can we come up with? How many numbers are there, how many values on our number line in the real numbers are there that would make this inequality true? And the answer is an infinite amount of numbers. As long as we're bigger than 7, any number on the number line that is larger than 7 will make this inequality true. And this is where our inequalities are a little different than our equations. Our equations had 1, maybe 2 values that would make it true, or it was all real numbers. You can notice we do have an infinite amount of solutions, but it's not all real numbers. It's only the real numbers that are greater than 7. So what we have to remember here is that a solution is still something that is going to make our inequality true. Right? And there are an infinite amount of numbers that will do that. But our strategy for finding those values is going to stay the same. Same as our single variable linear equations, we are going to be isolating the variable with our single variable linear inequalities. As we saw before, all of those steps, all of the strategy that we used to get x alone is going to stay the same. This leads us to two big differences, though, in our actual steps of getting the variable alone and to solve our inequality, right? Now, the first one has to do with what happens when we multiply or divide by a negative number on each side, and that's important, on each side of the inequality. You must, well, let's check it out here. So if I have negative 5x is greater than 25, and I divide both sides by negative 5, that would give me x is greater than negative 5, right? So since all the numbers that are bigger than negative 5 should be solutions, that means 1, the value number 1, should be a solution, and it should make our inequality true. So let's check it out here. So if I plug in 1, negative 5 times 1 is negative 5, and that leaves me with negative 5 is greater than 25, which we can see is obviously false. So we can see that 1 is not actually a solution. So what happens, though, if we flip the inequality sign there? right? So now instead of having x is greater than -5, we have x is less than, smaller than -5. Well, that would make -6 a solution, because -6 is smaller than -5. So let's check. If I plug in -6, -5 times -6 is 30, and 30 is greater than 25. That's a true statement. That's a true equation. So that means -6 is a solution. So what do we learn about what we have to do when we multiply or divide by a negative number on both sides with an inequality? We have to make sure we flip the inequality sign. And guys, this is a really important, simple thing, but it is one of the most often made mistakes. And if we're focused on do our solutions make our inequality true, then we will make sure we can remember this difference here. Okay, so the second difference here is that there are an infinite number of solutions, right, to every inequality. And it's impossible for us to list all of them. So how can I represent all of the solutions if I can't actually write them down? Well, we're going to represent the solutions on a graph here. So first thing we've got to realize is that our inequality signs are going to be different. So if we have an inequality sign that is just greater than or just less than, we are going to plot an open circle on the number line. What an open circle communicates is that the value the graph starts at is not actually a solution. It's where we're kind of starting from, but we're not including that value in the solution. So if we have the inequality here, x is greater than 5, you can see we put an open circle at 5, and then because x is greater than 5, I drew a line above the graph going to the right, all the numbers that are greater than 5. Notice I did not try and put a bunch of numbers on the number line. Notice I had the number that we're starting at, where I'm putting the circle, and then I had one integer to the right and one integer to the left. And that's what we're going to be asking of you when you're graphing these number lines. The number you're starting at with the circle, one integer to the right, one integer to the left. No decimals on these tick marks. Notice I said integers. So what happens, again, this is saying, that 5 is not included in the solution, but every number bigger than 5 is a solution here. So what happens when it's greater than or equal to or less than or equal to? Well, then that changes slightly the circle we put down. We're going to use a closed circle. And a closed circle is telling us that we do include the value on the number line here. So you can see we include -3, one integer to the left and one integer to the right with -4 and -2. And this is less than -3 are the solutions. So we're going to graph every value that is to the left of -3. And again, the closed circle is telling us that it's everything to the left and including -3 as a solution to our inequality. Okay, so now we're finally ready to start solving. We've gotten all the details and the facts out of the way. We know what's different about inequalities. We know what's the same about inequalities when we compare them to equations. So let's get into it. We can see we start off with a two-step inequality. The first thing I do is add 9 to both sides. Then I divide by 11. I'm going to get x is greater than 4. Then I'm going to put an open circle because it's just greater than, and I'm going to graph everything to the right. Now in B, you can see we've got some parentheses, and I've got like terms on the same side on the right, and I'm going to end up with variable terms on both sides. So I'm going to distribute the two, then I'm going to combine 5x and -x, then I'm going to subtract 2x from both sides, then I've got a two-step inequality. I'm going to subtract 8 from both sides, and then I'm going to divide by 2, and I'll end up with -8 is less than or equal to x. Now again, this is where we've got to be careful here. This is saying that -8 is smaller than or equal to x. So it's a closed circle, but x is bigger than -8. So just because the variable, the inequality sign looks like it's pointing left, we've got to be very careful to read the inequality and not graph our solutions going to the left of -8 where they're smaller, but to the right of -8 where they're larger. Okay, so make sure you're paying attention to what the inequality sign is communicating. In C, you can see I have to divide both sides by a -6. And you can see when I did that, I flipped the inequality from a greater than or equal to a less than or equal to. Again, closed circle, x is smaller than -5, so I'm going to the left of -5, and there I've got my solutions. I know I went through these pretty quickly. If you have questions about these, please write them down and bring them to class. But again, if it's questions about the steps in the solving, about getting x alone, those are things we expect you to know at this point, and you need to make sure you're coming outside to get help. We're happy to help you. I'm happy to help you, and the MARC teachers are happy to help you, but you got to make sure you're doing it. So here are 3 inequalities that we want you to solve on your own. In a second, I'll ask you to pause the video, but make sure you show your work in your notes or you won't get credit for them. Ready, pause. All right, let's see how you did. Hopefully, you got h is less than or equal to -5 and graphed it. You got x is greater than 3 and graphed it properly. And you got k is less than -1.31. And now notice, I'm okay with you using a decimal when we're graphing it on the number line. But the number to the right and the left still have to be the correct integers that the decimal would fall in between there. We can't put decimals to the right and the left on our tick marks there. Okay, well, that brings us to the end. I know we kind of sped through this a little bit quickly, so if you need to pause and rewind and go back to something, please do it. And if you have questions, come to class ready to ask them. We'll see you then.